Hello everybody, and welcome back to the channel. This is Michael, KE4EST. And today on the workbench, we have an Eico 330 or 330 solid state RF signal generator. This generator was sold as a kit form and came out around 1969. Went up through the 70s and kind of fizzled out around mid 70s, something like that. And you can see this one here is missing some of the embellishments on the knobs here. Got one. I got this one at Hamfest back in the summer for 20 bucks. And in doing a little research on this, I see some of these are going on eBay for $300, $400. But I seen one the other day that ended up, I think, ending at $50-something. So I think what it was some guy had one of these, thought it was worth gold, and put it on there for $400. Another guy come along, had one for sale, and says, "Hey, let me look it up and see what it's going for before I put one up." Oh wow, you can sell them for $400, and so he sticks $375 or something like that on his. And he's probably thinking, "Well, I'll make mine $25 cheaper and sell it faster." And as of making this video, and I look, they're still both sitting there. Nobody's bought those. But if you go to the search history or the purchase history on eBay and look, you can see that they're not really selling like that. So when I first seen that, I was like, "Whoa, what in the world?" I paid $20 for this, and I could have got it cheaper. It was one of those situations the guy just pulled up after I'd been at the Hamfest for a while, and he kind of got swarmed with people, and I happened to be in the right place. I went over and I seen this. And, you know, I looked at some of his other stuff. I'm like, yeah, I seen this. And I was like, I kind of like that. And I said, "How much you want for that?" And he goes, "Make me an offer." And I said, $20. And he said, "Sold." You know, I might could have went lower. But anyway, they're a decent little unit for a hobbyist or whatever. They hold pretty steady. You want to double check them with a frequency counter. You know, because, you know, it's got analog here. Now if it's something you're tuning up an old tube radio or something, AM band, whatever, you're probably fine as long as it's been aligned recently. But you need something a little more critical. You'd want to run a frequency counter with this. So anyway, so it's got you can see the band selector here. So this one will, you can actually leave it running. This is an on off switch down here. I can put it in RF off just to shut the RF output off if I want to just leave the unit running. And even though it's fully solid state, you know, sometimes you want to just keep everything running like it is so it don't change anything, shift a little bit when you shut it off. So you want to shut the RF off, you can just go all the way to here, and then you don't have any RF coming out of this jack here. Or if you just want to, don't worry about any RF running, but I want to use the audio oscillator built into it. You got an output over here. And then go to band A all the way around to band E. And it goes from 100 kilocycles all the way up to 54 megacycles. Or 100 kilohertz, 54 megahertz. So that'll catch everything up through, from audio all the way up through 6 meters. If you wanted to. And that was probably what they was kind of aiming for, the radio amateur. You know, you want to line your radio, your rig, or whatever. And as long as your IF is not one of them higher IF second or third stages or whatever, you know, you'll be fine with this here. So, and then you got the RF fine control here. And that kind of works with this course. If I've got RF set to high, it's just everything this thing will do as long as this is turned all the way up. And this is completely variable. All the way down from 0 to no RF out. This will be half of what it can do, you know, 50% all the way up. If I come to medium, it throws in a 20 dB attenuation. And then it'll be, this will still work here, but you've got 0 to 100 of half of what it can do. And then of course over here you got low, and that throws in another 20 dB of attenuation, so that gives you 40 dB maximum. And then of course you got this here to adjust to. On the signal selector knob, we got the power off, and it's in red here, so you can see that it's different than this off up here. This is actually shuts the unit on and off, and up here is an indicator. I've not looked at all the schematic yet, but it's probably, I've got it over here, probably a neon. Yeah, it's a neon bulb. And this here, when you turn it to this position, this is your RF position. As long as you got this here and say this set here, and then whatever you want to tune in, you got RF coming out here at the jack. And when I go here, this will turn on an internal modulator, 400 hertz tone that's mixed with the RF and coming out. You know, here's just RF only, just a dead carrier. This throws in your 400 hertz tone. If I go here, it'll be an RF plus whatever I'm feeding in here, which I think you can feed like, I was skimming over the manual, I think it's 15 or 20 hertz all the way to 15K, which you can probably go a little higher than that or so, but then it's going to be Y, you know. But and then this here, if you put it over here, like you can put it over here as audio out, say shut the RF off, I don't want the RF, and this will put the 400 hertz on this jack here. If you want it for whatever reason, need a 400 hertz tone to feed this into something else, or just used it for testing an audio amplifier or whatever. And then here's your output and your modulation. If I'm using it like I've got it now in this audio output, this would be 0 to 100% of the waveform on the 400 hertz sine wave. If I'm over here in internal modulation, this will adjust how much modulation I'm applying to this RF signal that's coming out over here on this jack. So there's a rundown of that, and it's so pretty decent condition, except for these are missing. It's dirty, needs to be cleaned up. Should clean up really nice. It's got 4 screws in the back that you take out to slide it apart. I've already taken them out to speed things up a little bit. So what we got to do is just grab it and kind of slide it forward gently. Pull the cord through there. See that? See, there's some dust in the bottom before it's been setting, but other than that, it's pretty clean. Let me get this out of here. And we'll turn it around, look at the inside here. Okay, so here we got there's your LC network, you can see, for the different bands. And there's your 10 capacitors. And those coils are probably, yeah, they got little slugs in every one of those coils. So, and it's easy to tell if you look at the size of how much wires on the wound around each coil form. This one over here would be band A, or your out down the audio portion, and this up here would be 54 megahertz side, which is what? Let's see, band E goes 16 to 54 megahertz. So that'd be that one there. Then you can trace it off and look at, like this one here would be the 54, yeah, that'd be band E and all around, maybe. Sorta. As you can see how this one here is coming off here. So this would be band D. And this one here is A, B, and C, looks like. Just a quick glance at it. And then you've got your main tuning capacitor here, which you can see. You can see it better that way. And you can see it's got a gear. Let me zoom in on that a little bit. See, it's got gear here. And 1. It feels like a 3-to-1. I've not looked at the, remember what the manual said on that, or if I've seen that, but it's gear reduction, so I can fine tune easier. If it was just straight wham wham, you know, that was it, it'd be a lot harder to zero right in on something. And it's not too bad. While I'll get it zoomed in here, you can see it's got a little bit of surface dust, but pretty good shape. And whoever put it together, so far it looks pretty good. This here could be brought up maybe a little there. Not too bad. Just remember, these was put together as a kit. So, alright, so let's look at the circuit board here. These two capacitors here, 100 microfarad, 500 microfarad, this will be your, you can see those little diodes down in there, those little white looking things. So this here be your power supply filter capacitors. Not sure what that one is, and that one's a Rubicon. But even though it's a Rubicon, listen, back in here's a Rubicon. There's another one over in here. With the age of it, I'll still just go ahead and change all these electrolytics out. And it looks like all the resistors are, yeah, let me see if I can bring you in here. Come on, focus. See how sharp that body squares off right there. So that's Allen Bradley style, and they look every one to be Allen Bradley except for some carbon films here. There's 1, 2. 2's all I see. The carbon film. And hopefully these transistors are good. Sometimes these older units, it's hard to get the transistors, but most of the time you can find a modern equivalent and something that's really close and replace it. But the rest of the capacitor, disc capacitors, are probably fine. So I have to go through everything and double check it. We'll look at the bottom here. See how they done this. What is that? Oh, okay. That's your. Let's see if I can get this so you can see it better. This capacitor here. This is your, I'm looking at the front here, this is your AF gain knob here on the front, so that'd be your audio coming off. Most likely coming off your audio oscillator and then feeding another stage, or maybe probably feeding back into the modulator maybe. Another Allen Bradley. Let's see. All that down in here. Here's your see this here. Right in here is your attenuation network here. And that's all. Oh, wait a minute. Yep, everything's Allen Bradley in there. Also, so you can see the line cord coming in here. Let me back off. You can see this line cord coming in, going to here, this terminal tie strip, coming over here all the way to the front here where this switch is I was telling you about for power on and off. So I got it right all the way over here to that switch. And here's your power transformer, which don't have to be very big for this. Anyway, you can see the wires come down to the circuit board. So that would come back up to right there, those diodes. So, yep. So that's full wave. So you got a center tap, which is probably this one here. should go, yep, comes right over the ground. Actually ties right into this, and this ties into the chassis. And also you can see they did a good job of helping with the RF. See the circuit board's soldered here to the case, soldered back there, soldered down here. And looking at the solder, not too bad of a job, whoever put this together. So that's what's going to be done. Check all that out, change out the electrolytics, and then fire it up and see how she'll do. And clean up maybe some of the surface stuff. Look at that coming off on my fingers there. So let's have a look at the schematic here. If I can put this in the shot. I printed out on 2 pages the way I found this PDF. So basically, not a whole lot to it. You got your power coming in over here. There's your neon bulb. Yep, see there it says red, yellow. Yep, so that'd be your ground full wave rectifier. Coming off here, yeah, those are 2 filter capacitors. So just a standard pi network, and that feeds your voltage off there. And you can see all the transistors are getting their voltage, and other places that need it. But really, let's see, let me start over here. I think this right here would be this your RF oscillator here. See how it's coming back up here and back in. That's called a bootstrap. It's just very, changing the impedance on the input to get to where they want it there. Is really all that's doing there. So let's see here. Emitter comes off. Yep. Down into the network here, and there's your different bands and your switching. I don't want to try to follow through all that on here and confuse you, but anyway, there's all that. So we just need to come back up somewhere. Here it is. Back up here. Here's your feedback right here. Keep this baby oscillating right here through this capacitor to the base here. So, and then let's see your next stage here. This would be, look at this a second here. This here's got to be your modulator. See where they got this choke coming off of here. Grounded that. That's coming off here. Down. Okay. Yeah, there's your modulator. So all this here is doing here is just buffering. This is just coming off, coming into here, buffering. And then they're coming off of here. So here's your fine adjustment. And then here's your output coming in here. And down and around. AF modulation control right there. Let's see, here's your, well, it says it, somebody's wrote it on there. Here's your audio oscillator. This makes your 400 hertz tone. That would come around. There's your gain. And what does that say? Distortion adjust. Yeah, this is, you'd set this here to get the minimum distortion when you're doing an alignment on it, so that you have a nice clean, tone. And then coming out here, there's your audio adjustment. Your modulation comes through the switch, back around, back into the modulation. Yep, and then Oh yeah, there's the audio in and out jack right here on this, and this switch will change whatever. So you want to bring it back up into the circuit, you want to take it out. Okay, so that's pretty much the schematic there, and everything is, let's see, somewhere this thing here. Let's see. Yeah, there's 20 to 1500, 15 kilohertz. Tells y'all this is definitely not made for 230 volts or anything, or 240. Don't weigh much. And there's your circuit description. Yep, buffer stage. Modulator, blah 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 blah. This is all online if you want to get it and read it. Tells all about it and how it all works, and it's even got somewhere, I think I've seen it. What is this? Oh, how to use it somewhere. Yeah, here it is. This here, under this small little section of maintenance, but it tells you here, like your some voltage measurements on your different transistors, from the emitter, base, and the collector, diodes, stuff, so that you can kind of go through and troubleshoot and say, not getting this and this, that. Q1, I'm getting 2 volts, and I'm getting 0 volts here, or whatever. You can say maybe it's Q1 is out, you know, whatever. So, and it goes over the whole alignment procedure, also, which I'll go over when I get it all recapped and checked out and all that stuff. So, and you can, let's see, we'll go over some of this in part 2 of this video, but I'm just curious. Those, yeah. So that's this tuning tool here. This standard, most of them's got this hex tuning on it. Tune those. Now for these here, you wouldn't want to use like this little plastic tip here. You can see, you know, you just twist it off with these being that tough metal. You don't want to use. You could use something like that. Let's see. Yeah, it fits right in there. A lot of times when I use one of those, it's something like this here. You see it's got that little piece of metal inside of it there. That's what I'll use. I'll run it in there like so. And, well, sometimes it's aggravating. Some of them are easier to. This one here is kind of small. Run it in there and find the slot like that. That way you've got it kind of not going to slip off as bad as if you had one of these, but no big deal. You wouldn't want to use a full metal screwdriver or something like this here, because all this metal here will change your capacitance, and it won't even fit anyway. So, but you wouldn't want to use something like that, or a jeweler screwdriver, something, especially jeweler screwdriver. You got your hands actually touching it. That's really gonna mess up your alignment. But anyway, let me get this all recapped and checked out, and then I'll go over anything I found and what I did to it, clean it up, and we'll do an alignment on it, and we'll hook it up, see how well it works. So, until part 2, and until the next video, this is Michael, KE4EST 73.